All right, continuing. So this may be a second video, but it's the same stuff. So what I was saying with the chain rule is, I showed you multiplication. Let's do one we just did. Let's say that you had x to the 8th, y to the 12th, z to the 5th being divided by x to the 5th, y to the 8th, and z to the 4th. Well, if you just focus on like bases, your answer is going to have x to the 3rd, because the rule is to subtract. Your answer is going to have y to the 4th, because again we subtract. What about 5 and 4? Well, that would be to the 1st, so really we could just call that z. And now we're kind of using rule 1 as well. That'd be my final answer, because x, y, and z are all different bases. I can't put those together. One more chain rule where you're using other rules, but you're putting it together with several bases. Still rule 6. Let's say you had 2x y to the 4th, and all of that was being raised to the 3rd power. Well, let's start with 2 to the 3rd. You've known how to do for a long time, so don't reinvent that. 2 to the 3rd is 2 times 2 times 2, which is 8. But then we could use the rule that we learned, rule 4. We have x to the 1st, because that's an understood one, being raised to the 3rd. The rule is to multiply those exponents, so now we're going to just have x to the 3rd. And the same thing for y. Y to the 4th being raised to the 3rd would be y to the 12th. So final answer, 2 to the 3rd is 8. X being raised to the 3rd power is x to the 3rd. Y to the 4th being raised to the 3rd power is y to the 12th. Chain rule, just treat each part of the problem as its own problem, and then put it all together like a chain. So here's the generic form of rule 6. So you've got a to the m, b to the n, c to the j. And this isn't the only form of it. We know we've already done several problems, but we would chain this problem and multiply, almost like the distributive property, multiply, multiply. So a to the MP, b to the NP, c to the JP, because if I don't write it there, you know these are being multiplied together. So the chain rule just means you can use the rules however you want, over and over and over, as long as you're sticking to things that are the same. A's and A's, B's and B's, X's and X's. All right. And I think this is the main last rule we're going to learn, and involves negative exponents. You are not allowed to leave a negative exponent. In math, somebody a lot smarter than us has decided that we're not going to leave it that way. And so there's a way around that. And the rule is you make a fraction out of it. You take that base to the bottom of that fraction. You make that exponent positive, and you put a 1 on top. So 3 to the negative 2nd power is really 1 over 3 squared, or you know 3 squared. So you could go further if you wanted to with this problem. Answer is 1 over 9. Don't worry, I'm going to work several of these. Let's say you had x to the negative 5th. You're not going to leave it up like that. You're going to call it 1 over x to the positive 5th. Let's say you had 2y to the negative 3rd. Well, you know you can't leave that. So the y to the 3rd is going to be coming to the bottom. Normally we have a 1 as the top of our fraction, but what do we have right here? Oh, we got ourselves a 2. That'll be the top of our fraction. Now let's see how this works in conjunction with other rules. First, I'll give you the generic a to the negative n has to equal 1 over a to the n. The negative becomes positive and comes to the bottom of the fraction. All right, here's the fun part. Let's put it all together. Let's say we had 5 squared over 5 to the 4th. You learned earlier that when you have the same base, 5, and different exponents, that you can subtract. Well, 2 take away 4 comes out negative. But now you have this new rule that does not allow you to leave your answer like that. So you're going to go one step further. And really, this is a problem where you know what 5 squared is, so you could actually go all the way to the answer of 1/25. Pretty awesome, huh? Don't worry. We're going to see rule 7 again. What if you were trying to do j to the 4th times j to the negative 10th? Oh gosh. Well, what's the rule? This goes all the way back to rule 1, or not rule 1, but rule 3. We've got same base. We're trying to multiply. What do we do with the exponents? We add them. Well, when we add the 4 and the negative 10, apologize for my writing, what do we get? We get j to the negative 6, but we know we're not going to leave our answer that way. So this problem would have an extra step of 1 over j to the 6th. And I know what some of you are thinking, so I'm going to work it a separate way. This is good stuff, good stuff. Coach, when I saw j to the negative 10th, I changed it. I'm a good student who's been listening, and I changed it to 1 over j to the 10th. All right. Well, now when you multiply, this is j to the 4th over 1. So you'd have j to the 4th on top. You'd have j to the 10th on the bottom. Your rule is to subtract. What's 4 take away 10? Negative 6. And you're right back to where I was. So I'll come over here and write 1 over j to the 6th. And some of you that are really smart will learn that with the subtraction, to put the answer where the bigger number was. So 10, bigger than 4. The 6 ends up going on the bottom. The 1 has to go on the top. Awesome. All right, so these last few will just be combo. See if you can handle some crazy combinations of the rules. How about 3x squared times 2x to the 5th? What do you think the answer is? Let's start with, don't forget how to do math you already know how to do. Do you know how to do 3 times 2? Yeah. For a whole long time in your life, that's always been 6. So let's get that out of the way. Now, going back to rule 1. I keep saying rule 1. That's not rule 1. That's rule 3. X to the 2nd times x to the 5th is x to the 7th, because we add those exponents. Final answer. How about, what do you want to do? Let's go 3b squared c to the negative 4th power. Whew. Well, let's take it separately. Let's chain it. This is 3 to the negative 4th. We'll deal with that in a minute because this is a 1, understood. What's the rule? Multiply. What about b? And b negative 8th, because the rule is to multiply exponents when you have a power raised up to another power. This is also c to the 1st. So when we perform our power raised to a power and multiply, we get c to the negative 4th. What's the problem with all those? Well, rule 7 says no negative exponents. Since all of these are negative, we could just take them all to the bottom and make them all positive. And if you're a person that doesn't want to leave a number the way it is, anybody know what 3 to the 4th is? I do. It's 81. So this would be a perfectly acceptable answer. Except that my writing's pretty bad. One over 81, b to the 8th, c to the 4th. What else you want to do? Oh, remember when I said that weird rule? Rule 2. Rule 2, and we'll go back over all the rules before we call this thing over with. Rule 2, anything to the 0 power was 1. Now you're going to see why. Let's say you had a to the 8th divided by a to the 8th. Well, using common sense, what's anything divided by itself? 1. You know that. But let's say you aren't using common sense and for a minute you tried to apply the rules. Well, the rule is to do what to the exponents? When you have division, you actually subtract. Well, what is 8? Take away 8. It's 0. Well, anything to the 0 power is 1. So that rule 2 that's so weird actually makes all the other rules work. What if you had x to the 4th times x to the negative 4th? What's the rule? Add those exponents. What's 4 plus negative 4? 0. Anything to the 0 power is 1. You're telling me x to the 4th times x to the negative 4th just comes out to 1? Think about it this way. What is x to the negative 4th? You've learned that it's 1 over x to the 4th. So another way to do this problem would be to change that to a fraction, multiply across the top, multiply across the bottom. Anything divided by itself again is 1. Or if you're trying to use the rule, subtract those exponents, 1. So here are all the rules. Rule 1. A little review here. Rule 1. Anything to the first power is itself. The generic way we're going to write most of these rules involve the letter A. A to the first is A, not 9, A. Which means we need to understand that rule goes both ways. All right. Rule 2. I'm getting sick of this one, but it's very important. Anything to the 0 power is 1. Rule 3, like bases, and you're asked to multiply, the shortcut is to add those exponents. Rule 4, if you've got to raise a power up to another power, the shortcut is to actually multiply those exponents. Rule 5, same base, but you're dividing. The shortcut is to keep that base, subtract those exponents. Rule 6, kind of a catch-all, just means you can chain. What do I mean by that? Any rule you want to think about that we've already done. like this one. What's the operation? Division. What do we do to shortcut it? Subtract. But only deal with things that are the same. So let your x's and x's go together. Let your y's and y's go together, and then put them back together for your final answer. It could be rule 3, could be rule 4, could be rule 5. Any of those can be chained. And then finally rule 7. A new one, but a big one. Don't leave things with a negative exponent. Make a fraction out of it. Make the exponent positive. Put the base and the exponent underneath in the denominator. So that is the rules of exponents. We're going to have some assignments over that later. But for now, I just want to get that to you. And don't worry, you're going to have typewritten notes. You're going to be able to ask me questions. Everything's going to be all right.